everyone, good day. Algebra, we are at our last objective of our unit, talking about an arithmetic sequence, which kind of goes along with other things we've been talking about with equations. It ties the math packet with that pattern block page. But you were given the task here of a table with time related to distance. What will the distance be after 5 seconds? And if you answer this, be prepared to explain how you found it. We're given the first kind of 4 data points here. After 1 second, distance of 16 feet. After 2 seconds, 48, 3, 80, 412. What will it be after 5 seconds? Aiden.
I found out that the distance was going up by 32.
Okay.
So I just added another 32 to 112.
Sure. And you got what?
I got 144.
Okay. So the distance will be 144. And how he knows that is he recognized this pattern of plus 32. Every second that passes, it's going 32 feet further. Raise your hand if you also notice that pattern. Yeah, good. So then finding 5 seconds isn't really all that challenging because you just go another 32, and that brings you to 144. Okay? But the point of algebra, and we'll see this a lot as we go further, is we want to look for patterns, which we have here, and then use that to write an equation or a formula that's going to help us get stuff that's further out. Like I asked you here for the distance after 38 seconds. I do not expect you to write this table out to 38 seconds. Was anyone able to come up with an equation, a formula, or a rule that they just plugged 38 into, and the result they got was the distance? Anybody? Anybody get started? Kind of, maybe, something to work with here, Maggie? And you did that how many times? So that's to get 5 seconds, yes. But how about to get to 38 seconds? Okay. Well, no, I mean, you didn't do it wrong for 5 seconds, but we're down here at the 38 seconds. Aiden?
Well, I just did the same with the 42 rule, except I took 4 off of the 38 because you already know how much the 4 is.
Okay.
And then I just said 34 seconds times 32.
Excellent. Yeah. Aiden kind of realized, okay, if I want to get to 38 seconds, and he stopped it right here after 4 seconds, how many more seconds pass to get to 38? If we already have 4 seconds, how many more seconds pass to get to 38? 34 seconds, right? And so what Aiden said was, well, rather than adding 32 another 34 times, multiplication is repeated addition anyway. That's what it is. 34 times 32 is going to get the rest of the way, okay, to 38 seconds. So Aiden, what did you get from 34 times 32?
1,100. I mean, not 1,100. I got something else, but I added 112.
So what?
Oh, I actually did get 1,100.
1,100 exactly?
I think so.
Not sure it's 1,100. I believe it would be like 1,000. Yes. 988. Yep. Because now what would we need to do to this to get the total distance? Because what we just found here was, we're at 112 at this point. It's 988 more feet to get to 38 seconds. What's the total distance?
1,100.
Not 1,100. That would just be plus 12. We want to add 112. So 1,200. Okay. Everyone see how we got that, or how Aiden did it? Okay. He's saying I've got to go 34 more seconds to get my total of 38. So 34 times 32, because you're adding 32 each second that passes here. 34 times 32 is 988, plus the 112 I already have, brings me to my total distance of 1,200. Yeah. What'd you do?
No, I mean I got like 1088.
I'm sorry, that would be right. 1088. Thank you. Thank you. Is that what you're going to say too? Thank you. Okay. Anybody else have other thoughts? Okay. So it sounds like most of us didn't really know how to calculate this 38 seconds without just adding 32 over and over and over and over and over again. Yeah.
Would it be okay if instead you did it off of 33 times 32?
Sure. Yeah. If you since we found this answer here to be 144, you could do 33 times 32 because it's 33 more seconds to get to 38 and do it that way as well. Did anyone do it that way? Anyone do it a way similar to what we had here? Couple? Okay. So most of you still, it kind of sounds like didn't really know where to go from here. Okay. Sarah?
How did you get to 34?
Because Aiden stopped it after 4. He didn't include the 5. So after 4 seconds, there are 34 more seconds to get to 38. And so that's why he multiplied 34 by 32. Samara stopped it after the 5 because she knew what the 5 was, 144. So she multiplied 32 by 33 because there are 33 more seconds to get to 38. Okay? But for those of you that weren't quite sure what to do or how to go about this, we have what's called an arithmetic sequence, okay? Which is what this is, because the definition of an arithmetic sequence is a pattern with addition or subtraction, okay? A pattern with addition or subtraction, which is what this was, right? Because what was our pattern here? What'd you use to get the distance after 5 seconds? Adding 32, right? So that consistent pattern makes this an arithmetic sequence, and this can go on a help sheet, this whole section here. I highly recommend you put it on there. This is the formula for an arithmetic sequence, which looks kind of variable-y, okay? There's a lot going on there. And so we're going to identify what each of those variables represents and then look at how it relates to what we just did. We're going to put it back to that table there, okay? So the AN is going to remain an AN because it's our answer, okay? It's what we're trying to find. So there's not really anything to plug in for that. But in the example up above, we were trying to find the 38th term of this sequence, right? Starting at 1 second, going to 2 to 3 to 4 to 5. We wanted to go all the way up to 38 seconds, which means we were looking for the 38th term of that sequence. That's what we wanted to find out. Yeah. What does what say? Oh, what we're trying to find. Sorry. I'll make it neater.
You should just type.
If I typed on this, the format would be all screwy. It would really, yeah, it would mess everything up. What I should do is just write neater. This is a problem that I can fix. Yeah.
What's that thing? Is that a cave?
Where?
Yeah.
Oh no, that's the like 38th.
That's a cave.
No, it's 38th.
Oh,
Like the 38th term. 38th term.
you need handwriting lessons.
38th term. I apologize. Okay. The A1 represents the first term of the sequence. Better?
Yeah.
Yeah? Huh? See, I can do it. I just got to want to do it. The first term of the sequence, which in our table up above, what was the first term? The value after 1 second, or the distance after 1 second was 16. Okay? So the first term of our sequence up above was 16. Okay. The n variable represents the number of the term we want to find. The number of the term we want to find, which again is going to match this answer piece, right? Because it's what we're looking for. So the number of the term we want to find is 38. That's what we were looking for, the distance after 38 seconds. Okay. And the d variable represents the common difference, it's called, which is a fancy way to say the pattern. You know sign language? That's impressive. Very good. Awesome. Yeah. The common difference, so now instead of stop talking, I say stop signing, okay? Which is the pattern, which for our example up above was what? What was the pattern? Leah? Yes. Add 32. And because we're adding 32, we're going to make that 32 positive. If we've been subtracting 32, it would be negative. Okay? So I'm going to write this formula down here. Okay? And then plug in the values that we just identified. AN is the answer, so we don't have anything to put there yet. It's going to be 1200. We already know this, right? We already solved it. But the A1, the first term, is 16. You can always tell what the first term is because it's what you start with. Okay? It's your starting point. And then to that 16, we're adding the number of the term we want to find, the 38th. That's our n. And we subtract 1. Why do you suppose we subtract 1 from 38? Which really ends up being 37 here. Right? Because that common difference being 32, we're going to multiply this by 32. Why do you suppose we ultimately take 37 times 32 and not 38 times 32? Any thoughts? Okay. The reason is because, we already have our first term. And so how many more terms do we need to get to our 38th? We need 37 more. Okay. So this minus 1 oftentimes gets forgotten in the formula. But the reason why we subtract 1 there is because we're looking for the 38th term, yes. But because we already have the first term, that means we need to add 32 37 times to get to the 38th term. So in your calculators now, I want you to plug this in, type it exactly as you see it here, and make sure you get 1200, because that is the answer that you should come up with. We already solved for that. Okay, calculator, plug that in, make sure you get 1200 so you know how to enter it. 16 plus, and then parentheses, 38 minus 1. Close your parentheses, times 32. 16 plus, then in parentheses, 38 minus 1, times 32. Yeah. You will be allowed to use your calculator on this objective on the test, yes. Okay. Everybody not get 1200? Okay. And eventually you can do the, obviously you can do the 38 minus 1 in your head, right? So eventually you can move to just doing this, but you have to understand why you're using 37 and not 38. I already explained it. Who can summarize why we're using 37 there and not 38? Why is that n minus 1 a part of the formula? The answer is because we already have our first term. We already know what our first term is. Right? The first term of the sequence is 16. So if we want the 38th term, we need to add 32 37 times to get there. Okay, which is why we subtract 1 from the number of term that we want. Okay, we are going to, any questions on this that you can verbalize? Maybe you're confused but not quite sure how to ask it. Anything you can verbalize? Okay, flip the page and let's kind of look at another example here. All the way down to our bank account. It says your bank account currently has $160, and consider this day 1. You begin adding $8 every day. How much money will be in the account on day 50? So we're looking for the first term, the number of the term in the sequence we want, and the pattern, right? Remember that first term is where you start. Where are we starting here? Sasha? 160. Yeah. Okay. We're starting with $160. That's our first term. Aiden? Okay. What number of the term in the sequence are we looking for? What's our question, right? This n, remember the an part of this is the answer. What are we looking for? What's the question, John?
How much money will be in the account on day 50?
Day 50, right? So, like I said, the A1 is what you start with. Okay? We start with 160. You can find the n usually pretty easily by looking at the question. This question here is how much money will be in the account on day 50, which means we want to continue this sequence out to 50 days. And then the common difference, the pattern, what is the pattern here? How are we increasing or decreasing this amount of money? Connor? By 8. Okay? So then we go to our formula, which again is A1, or the first term, times n minus 1 times that pattern. Plug this in. Our first term is 160. We're adding 50 minus 1, because remember, we already have the first term. The 50th term is 49 days from now. So we're adding 8 49 times. That's why the minus 1's there. Go ahead and plug that into your calculator and let me know what you get. How much will be in our account on day 50 if we follow this pattern? When you've got an answer and you're confident, John?
552.
552. Lauren, is that what you got too? Okay. All right. Questions now that you've seen it again and it's not quite as much writing about it? Anything? Okay. We're going to stop here. We're going to finish this up tomorrow as well. Get your practice test for your test on Friday. So no homework for tomorrow. Enjoy the evening. Khan Academy is due tomorrow night. And your football pick'em for week 5 is due tomorrow night as well. Okay. That's all you math, folks.